I think I forgot to erase the history. Yeah, so today I'm gonna reserve 50 minutes for each challenge, I think, instead of 40, and we'll see how it goes. And then after the time runs out, I'm gonna see the solution. And then I'm gonna search the topics that I don't feel like I don't understand. Find a function that takes one integer argument and returns logical value true or false, depending on if the integer is a prime. Per Wikipedia, a prime number or a prime is a natural number greater than 1 that has no positive divisors other than 1 and itself. Requirements: you can assume you'll be given an integer input. You cannot assume that the integer will be only positive. You may be given negative numbers as well, or 0. Note on performance: there are no fancy optimizations required, but still, the most trivial solutions might time out. Numbers go up to 2 to the power of 31 are similar, depends on language version. Looping all the way up to n or n divided by 2 will be too slow. So I think I remember something from mathematics that about prime factorization, where you can pretty much break down any number into a prime, or something like that, where you just break it down by step. I don't remember really well how to do that. So let me think. I think also negative numbers are probably not prime, following this stuff. Greater than 1 that has no positive divisors other than 1 and so. Oh, so it should be greater than 1, so if num less than or equal to 0, turn false. Then else, then I put the logic here. So that takes care of the numbers that are not. So let me try to do the first thing that comes to my mind, which is if n divided by, oh, actually not. Because I think I can't take the remainder. Is a natural number greater than 1 that has no positive divisors other than 1 and it's so. So what I can do is divide by the first prime numbers, and then I can loop. So I know that primes are 1, 3, 5, 7, 9 is not, then I think it's 11, the next one. Then 13 maybe, 13, 17, 21, no, 21 is divisible by 7. Yeah, after 17, I think I don't know anymore. Maybe 22. So what I can do is try to divide the number by this first prime numbers. And that's gonna make the number smaller, and then I can do the loop thing divided by the remainder. But it feels like it's kind of like a hacky way to do it. Because the challenge is saying that looping is probably a better idea. So what I can do here. So it can only be divisible by 1 or itself. No, actually I can divide by a very large number first. Yeah, but then that doesn't take care, because if I divide by, yeah, I can do a smaller loop. Or I can divide the number each iteration and get the result. So I can make a variable equals to count, let's just say. Maybe I should stop using count, because now I know that this standard library has a count and countif function for vectors. So I think I'm just gonna use co equals num, and then I'm gonna do a loop, and I'm gonna divide. Oh, but then that's the problem. Maybe I don't even need to do the co actually. Now let's do the loop and see. I think later. I don't think I'm gonna use the new variable that I created there. I can do equal here. No. I plus plus. So what I'm thinking about doing is, if num remainder y, damn, yeah, there we go. So if the remainder is equal to 0, it means that you can keep going. So if the remainder is different than 0, return false. And then here I can make num equals I. So num equals itself divided by I. And that, what's that gonna do is just gonna decrease the size of the number each time that it loops. Yeah, but then the problem is that it doesn't get, because it's not gonna get to the final number. That's the issue. Yeah, so I can't use the loop actually, because I'm gonna have to loop through it anyway. So I think probably the way to solve this is the prime factorization stuff that I was talking about before. But I don't remember really well how it works. I think any number can be composed of primes and some remainder or something like that. And I forgot to read this stuff about auto in C++. Use of auto keyword as a data type of the variable after evaluation of expression. How does auto key work? C++. The keyword auto is used normally like other keywords in C++. Is used before the name of the variable or the function to infer the return type of both of them. When the auto keyword is used, it is evaluated at the compilation time. Since the compiler has to do this, it increases the compilation time to a few seconds, which is almost negligible. So it is used before the name of the variable to infer the return type of both of them. One of the advantages of using the auto keyword is that it reduces the extra overhead on the programmer to define the data type so that she can focus on other important tasks as well. Because of functions, using the auto keyword helps to create generic functions. You can pass different parameters to the functions with their data type as being auto. So the issue of creating separate functions for different data types can be easily solved by only one single function. I think templates do that as well. So it's probably similar to templates. But templates, I think you create one for each data type you want or something like that. I don't know really well. I have to look again after. So how to factorize any number into prime numbers. And maybe factorize is not a word. Learn how to factor into prime numbers. First, let's look at what factoring is. Writing a number is the multiplication of other numbers. Other cases are examples of factoring. Now we're going to look at what a prime number is. Now we'll divide by 18. Find out prime factors looks like. So you divide by the smallest one, and then you do that recursively. So let's think about this. I think any division that the remainder is not 0. No, but then the problem is that there are more prime numbers. And I'm not really sure if that's gonna allow me to see if the number is prime or not. By factorizing, well, it is, because if the only factors are the number and the number itself and 1, then it is a prime. So I think that's the definition. Now we know what factoring is and what prime numbers are. Factoring into prime numbers is writing any number as a multiplication of prime numbers. For example, we are going to factor the number 36. Let's choose a prime number by which 36 is divisible, for example, 2. Now we divide 18 by another prime number. Now we divide 9, and finally we divide 3, which is a prime number, so we can only divide it by itself. So 36 when factored into prime factors looks like this. You can also write the factors in the form of powers, so that the 2 is multiplied twice and the 3 is multiplied twice. Yeah, but the problem with this is obviously that it doesn't give me any insight on how to do that for this specific problem. Whole number greater than 1 that cannot be made. So obviously what I can do is create a dictionary with the prime numbers, the first prime numbers, and do what I was talking about to implement the check, but it still doesn't solve the issue of large numbers, because it might be possible that they are not divisible by 1 to 100, but well, actually not, because yeah, it might be possible to just test if the number is divisible from 1 to 100, because if it isn't, it probably is not going to be divisible by any other number, because any other number can be composed of numbers between 1 to 100. And that means that the number would have to be divisible by that point. Otherwise, it's a prime. But I'm not entirely sure up to what number that happens. It's actually an interesting thing to think about. Like, how many numbers do you actually need to create all the other numbers? I think it's just 10, maybe. 0 to 9. And if there is any number that isn't divisible by that, then it means that it is a prime. Because all the other numbers are going to be combinations of that. Well, let's try to do that. So I can make equals to 10 here. And then I can erase this. I'm not sure if it's gonna work, but turn true. So it has to be let me think. So it has to be true if it's a prime, I think. Yeah, it's true if it's a prime. So what's going on here? Maybe I have to take this off. Or maybe it's because I'm doing like this. Oh, but this is gonna make it start from 1, not 0. I can erase this number here. Oh, I probably forgot. Oh, here it goes with the else, so what's going on? Oh, I'm making it equal. I should be double, I think. Or not. Oh, I can't because even if I do it like that and it worked, it wouldn't run the loop, I think. Nation comparison results on this comparison. I don't understand why he's giving me that. Oh, I put a comma here. That's fine. Let me see if it's gonna work if I do it like this. I think it's not gonna run the loop. That's the problem. So I'm getting false and expected true. It's obviously the condition that I'm doing wrong here. So maybe I have to put like this. And I have to check for, has to be, I have to check, maybe if I do like this, I want to check if the number is not itself or not 1. So if it's not itself and is different than 1, and it isn't divisible, the remainder isn't 0. The remainder is 0. I should return false. Because it can only be divisible by 1 and itself. I'm worried that this, oh, actually, so I expected false and returning true. That should be the first one. Oh, so an easy way I think is to make it equal 1 here. To handle the first. I could just start the loop at 1 as well. Or at true, actually. So I can erase this part here. So phi is different than number. And the remainder of the number divided by I is equal to 0. Maybe I should be different than 0. No, because I'm trying to test. But that's the problem. I have to remove the prime numbers. Yeah, it can't be like that. No, but if a number is divisible by a prime number, other prime number, then it means that it is not a prime itself. I think. So I don't think it's necessary to remove the primes from 1 to 10 to loop. So why I'm getting false? Let's say for 3. 3 divided by 2 is not 0. So it's gonna keep going. 3 divided by 3 is 0. The remainder is 0. But the number is itself. So it should pass. Oh, there we go. Okay, so the more difficult tasks, I'm failing. So maybe if I increase here, let's increase to 100 an attempt. Now it should pass. So it's interesting that the number is not actually 10. But I wonder why though this happens. Because in my mind, any number should be able, you should be able to make, or maybe it's because you can have 2 primes. Yeah, like 121, which is 11 times 11. But I'm not sure if 121 is a prime itself. Yeah, that's the thing. I think that's what I'm missing with this solution. Is that there can be higher numbers that maybe if I try 1,000 here, see, but I suspect it's still gonna give me false. It's still not gonna pass, I think. It's gonna give me true and it's supposed to give me false. So I think what I'm missing here is the numbers that are divisible by primes themselves. No, but if a number is divisible by any prime between 1 and 1,000, it should be giving me the answer. So I think it's probably the condition here that I'm not thinking about it. There's something I'm missing. I wish I could see the task that I'm failing. Yeah, but it doesn't show what's the input. Maybe if I just count log, if I just standard counts, no, I forget the new line now. Hmm. Yeah, it's just a bunch of large numbers. Let's see if I increase the number here. What happens? Oh, there we go. Huh. That's really, really weird to me. How is this possible? So the thing that doesn't make sense to me is the thing that I was talking about on factorization, where, well, maybe yeah, it's probably because there are primes that are a lot bigger than 1,000. And then there are numbers that are composed by those primes only. And those numbers I wasn't testing for. I think that's the issue here. Because that's the only way that makes sense. Otherwise, any other number would be broken down between other prime factors at the root, I think. Yeah. It just makes me think about several different things. I don't think I need to put comments on this. I think I'm just gonna submit. I'm gonna see how much time I still have. So I did it on around 30 minutes. This number of prime. So I think I'm gonna add the next 20 minutes for the other challenge. 19 minutes. So instead of, it's gonna be 1 hour and 9 instead of 50. And let's see the other solutions. I really like this rating system. It makes you kind of addicted to solving these problems. Especially for my type of personality, which is very competitive. So let's see, it's square root of number. And that's an interesting way of thinking about it as well. So they did pretty much what I did, but in a slightly different way. I just don't understand this part here. If num smaller than or equal to 1, then false. Oh, it's probably because of the negative numbers. Yeah, that's why. And now it's true. I think this challenge was a lot easier than the previous ones. And is the same level, so. Maybe I'm just becoming better, or it could be that this challenge doesn't involve a lot of programming concepts that I'm not familiar with. It's more something mathematical. That's why it doesn't feel so hard. Yeah, so there's nothing really crazy in the other solutions. So I think I'm gonna move on to the next one. And I think I can do the same cat as I did for C++ with other languages in the future as well. Probably gonna do that. This time start the counter. We live in the city of Cartesia, where all roads are laid out in a perfect grid. We arrived 10 minutes too early to an appointment, so we decided to take the opportunity to go for a short walk. I think New York is like that as well. The city provides its citizens with a walk generating app on their phones. Every time you press the button, it sends you an array of one-letter strings representing directions to walk. North, south, west, east. You always walk only a single block for each letter direction. And you know it takes you 1 minute to traverse one city block. So create a function that will return true if the walk the app gives you will take you exactly 10 minutes. So each instruction is 1 minute and 1 block. You don't want to be early or late, and will of course return you to your starting point. So traverse. So create a function that will return true if the walk the app gives you will take you exactly 10 minutes. You don't should be early or late, and will of course return you to your starting point. Don't understand this part here. Return false otherwise. Also pretty much get the path. You always receive a valid array, string in COBOL, containing a random assortment of direction letters. It will never give you an empty array. That's not a walk, that's standing still. So I'm gonna receive a pointer probably. No, it says, yeah, a vector of chars called walk. No, isn't just getting the length? I don't understand. I put uint as equals walk dot size. I'm not sure if that's how you get length of a vector, but I'm gonna test it like this. Smaller than 10. It can't be that easy. I'm obviously missing something, but I just want to see if it works. Yeah, return true. Oh, I forgot to erase this. Yeah, so I'm obviously missing something. Let me see if I'm getting the size. What you get the length of a vector. C++. I think I'm receiving the whole vector through the argument. At least that's what it looks like here. And this char is just to declare the type of elements inside the vector. I can use count, I think. Maybe I should read the instructions again. You live in the city of Cartesia, where all roads are laid out perfect green. You arrive 10 minutes too early to an appointment. So I decided to take the opportunity to go for a short walk. The city provides its citizens. Oh, that's what I'm missing. So I have to calculate from the path. Now I get it. So the whole path has to take 10 minutes, but I have to come back to the starting position. That's the problem. So I don't only have to get I need to figure out a way to get the geometrical positioning as well. Yeah, that's a lot more difficult. Because depending on which path you go, it might take you longer to come back. Maybe if I just do the reverse of the thing. Well, if it's if it's less than 5, it's true. Because that means that it doesn't matter what path you took, you still have extra 5 steps, I think. Even if you go on zigzag, you can always come back through the same path you did to go. No, but isn't the same for any other path? Because you can't go in diagonals. So if you take more than 6 steps, more than 5 steps to go, then it means that you're not gonna have enough time to come back, regardless of what path. We arrived 10 minutes early. The city provides citizens with a walk generator app on their phones. Every time you press the button, it sends you an array of one-letter strings representing directions. You always walk only a single block for each letter. You know it takes 1 minute to traverse one city block. So create a function that will return true if the walk the app gives you will take you exactly 10 minutes. You don't want to be early or late, and will, of course, return you to your starting point. So it has to be exactly 10 minutes, I think. So maybe else if it's equal to 10, then return true. If that should be exactly 10 minutes. Turn false, otherwise. It's probably not gonna pass. But so I don't see what's wrong with this one. Let's see if I'm getting the size correct. No, it's dot size. So what am I missing here? It has to be that. It has to be less than 5. It has to be 5, actually. I'm not sure if this is the path, the full path, from the starting point until the beginning, or if this is just a path to go. And I need to figure out if I'm gonna be able to come back. If I do it like this, it's probably not gonna work. Biggest issue with this one is that I don't understand the instructions really well. Yeah, so this is supposed to be false. So it probably means that it has to be exactly 10. Let's see. 2, 3, 6, 7, 10. Pause. Yeah, I think it has to be equal to 10, but to expected false equals to true. Standard count as well, obviously it's gonna be 10. So what's the difference between these ones? Oh, is that it doesn't, the final destination is not equal to the beginning one. That's probably the thing. Huh. Let's see. Yeah, this one is symmetrical up to the up to this one, and then in the end is the opposite. Hmm. No, I don't think I get it. So the length has to be 10, but then you have to reverse and get the opposite for the last one. Yeah, so how to reverse a vector? And then I think I can do if west, then south. If west, then east. If north, then south. And vice versa. And it's gonna prompt me. Maybe we can use count to reverse. Yeah, I only need to reverse the first the first 9 elements to see if they are the same. But first, I need to, I think I have to see if the first element is the reverse of the last element. I think it's begin and end. Access here. A dot begin. S dot begin equals true. Solve and different than north. I wonder if there's a better way to do this though. So if it's not the opposite, return false. Yeah, I think this is probably redundant because I have to do it twice for. I can obviously use an OR statement as well here to check the other one, but I'm trying to think about a way where I can type just once to check if it's the opposite or not. How can I say this is the opposite of this? Maybe I can make it equal to variables. But then I can't, I would have to use a dictionary. Because I would use strings, positive numbers, and negative numbers. Yeah, it's only reverse up to this point. The last one it changes. And this is incorrect because this one is the same as this one. So if this was south, it would be correct, I think. I think I'm gonna do it like this, and I'm gonna see other people's solution to see if there's a better way to do it, which probably there is. So here, the only thing I'm gonna change is and solve for false. Oh, actually, I can't do it like this because first I have to check if it's a reverse or not. Oh, and this is actually true. No, this is false because I'm making different here. So I'm gonna do it like this, and then I'm gonna put this block inside the condition to see if the first 9 elements are a reverse or not. think I'm gonna use this. I didn't want to use it because I'm gonna have to use this library, but I don't think it matters that much. And then here it would be -1. Oh, it's not S as well. It's walk. Because I'm getting the vector and not the size. So now I make this equal to a variable. Has to be a vector. Standard vector char walk2 equals this. Here I'm making -1, so I get the element that is before the last one. If walk true. Now I'm not sure if I can compare them like this. Maybe I have to do a loop for that. Or I can use count or transform, something like that. Oh, the thing is, I also need to get the first 9 elements. I wonder if there's probably a way to do that, because I don't want to compare entirety of them. Yes, I'm definitely gonna use this one. Yeah, so I'm probably gonna remove the last element of the first vector and put it in another variable. Yeah, so I'm either gonna use this one or this one. And now I have to search how to remove. I'm not sure if I should use back here as well. Yeah, now I'm not sure if I'm comparing iterators or the vectors themselves here, which might also be a problem. So I can use this one. Not sure what the difference is between this one and the other one. And I'm not sure if they modify the vector itself. So now I make one equals the other, and then I put this stuff inside. Yeah, so if the reverse is equal, then I make these conditions. And then if all of them pass, then it means that. Now what if the reverse isn't equal? Then I have to make false. Yeah, now I think if all of them pass, it means that it's true, so it returns true. The last test. So both this walk dot pop back doesn't work, and this reverse doesn't work as well. Over viable conversion from void to standard vector char. So this returns, it doesn't return anything. And what's the problem with this? From void to standard vector char. Yeah, same problem. And also problems here because of the iterator stuff. I wonder if I use the index, it works. That would be easier. So doing like this. Just trying to find. So this works, I think. Not getting any errors for the first one, as far as I can see. So I'm gonna change all of this. I can just copy. It's easier. Yeah, so I think all the other mistakes were gone. Now it's just figuring out how to convert this. Because they're not, I think they are not returning anything, so it becomes type void. I wonder if yeah, probably can't. And the problem with this is probably gonna return an iterator. I think these functions are just to remove the elements. It modifies the original vector, which is not what I want. I can use copy, I think. Yeah. I don't know how to use it, but I know that it's possible. How to make a copy. Plus plus. Then I can copy from the beginning to the end -1. I think it works on vectors, probably. And I can probably do this outside of here. I can initialize this here. Now, if this works, then it's just a matter of figuring out this one. Yeah, so the reverse of Let's test this. Yeah, so I think this worked. And now it's just the reverse, the problem. And I can't compare this for some reason. Oh, because the reverse. And this one seems interesting. So it creates pointer for last, first and last. I think I don't understand really well how iterators work in memory. I think they iterate by one, and they don't keep the entire thing in memory, but um, probably that's why it's different. It's a different type of different type of data. Commutate the reverse of a vector by using range constructor to create a new vector with reverse iterators as parameters. You can then swap the original vector with the new reverse vector by using vector swap. We can say I use just this. Also has to be a walk. I forgot about that. Maybe this is the problem. Okay, so at least it works, I think. Or maybe not. Get an error. Undefined behavior. Yeah, so it's probably this stuff here. Let's see if I do this. The issue with doing this is obviously that I'm not getting the reverse. Oh, I can just use a small walk. Yeah, small walk should be the smaller vector. But maybe this is the problem, and not this. So I'm copying walk from beginning to end -1 till the beginning of small walk, which is this one. Then I'm gonna check if this is equal to its reverse. And if it is, I check the original one to see if it's the opposite on both cases. If it's different than the opposite, then returns false. And then I check to see if it is, if they are different, the reverse is different. Yeah, this is probably the mistake here. I'm still getting an error. So I have no idea what's going on. I think the challenge is easy, but the problem is this C++, these variables and these data types. It can't be here the problem, it has to be this true. Maybe I should just look at the library. Yeah, this is definitely something that I need to study more. How this data type works. It's the thing that I'm having the most issue with. I think here is passing the vector with characters. The element is char. So it should be creating the same type of vector here. Maybe because I didn't specify the size. But that doesn't make much sense to me because this also didn't specify the size either. Begin and begin. Yeah, but that still doesn't. It's gonna give me voids. I think I'll be right back. I'll go to the bathroom. Yeah, transform is not gonna work to pass. I think I'm gonna have to use the loop that I saw on the other. I think it was this site here. I didn't want to use a loop, but the issue is that I don't know if the copy is correct. Maybe I should watch these videos here. I'm gonna go back to this one and see how much time I have. Oh, 15 minutes only. I'll be right back. Might just go overtime on this one. So the is not giving me any audio, so I'm not using the thing.
Copy from that range into the destination. It's pretty simple. Let's take a look at the code in action. We've got a couple of containers here. I'm going to write those containers out just to show you what they contain. I'm going to run the copy, and I'm going to write out again. This function here, write to cout, is a template function, and I'll talk a little bit about it later on. But right now, all you need to know is it just fires out the container contents to the console window. And if we run this, you can see here we've got our containers here. They contain strings that are words and digit representations of numbers, and we're copying from the first one into the second one, and here's what we get. So it is fairly straightforward here. Give it the range to copy from, we give it the place to copy to, and it will overwrite what is in those places from the source range. Now, one interesting thing about copy is the source and the destination, they can actually be in the same container. There's only one restriction, and that is that your destination, it can't fall within the range of your source range. So it has to be outside that range. But as long as it's outside that range, copy is going to work fine in the same container. So here you can see my source range is at the beginning of B, my destination start point is just a little past the middle of B, and if we run this, we can see that, yeah, we're copying the beginning of B.
So it should work if I just put -1 here.
Into here, so we're duplicating that part of it inside the same container. We see that we're writing adapters to do things like insert using iterator adapter to create.
So it's just using b.begin. Alright, that's probably what I'm doing wrong here. It's walk dot begin, but I'm not sure if that makes any difference. So I'm copying from the beginning of the walk to the end, -1. And this is the vector, this is another one. Let's see if this gives me any problems. Yeah, so let me think this is, yeah. Okay, so the problem is this one. I think this one works. And this is the one that I get when I get the reverse. Yeah, just making the copy on the small walk and then but why am I making this copy in the first place? Well, just because I wanted to create a smaller one and not modify the original one. So now it's how to reverse this thing. I think I'm gonna try this one. So this is the vector. And then it's swapping. And I guess it modifies the vector itself. I can also use the first one because I don't need to put it on in a different variable. I can just reverse it. I'm already getting tired, to be honest. So let me do this. And then small walk. Oh, but that's the thing. Because I can also just make 2 different vectors. That's also a possibility. And it is gonna be equal to the reverse, right? So that's the W. Oh, it is not equal to the reverse, actually. It's just the same pattern, and then it ends on the where it began. Because it has to be like this circular thing. So the first var has to be equal to the next 4, I think. Oh, but there is not equal. Oh, it is equal. Up to here. Oh, actually, it's a double and yeah, this pattern is equal to this one, but it's separated by this n here. And so this has to be equal to this, but with the opposite in the final one. So I'm just getting confused actually to what I need to do. But this one is not equal to this one. Yeah, it stops here. But it is equal. It's equal to here and then it changes here. Yeah, I don't know. I'm getting tired. I think I'm gonna stop, actually, and see the solution. Even though I'm very close. The problem is this pattern here got confused. Because I know it has to be like a circular thing, obviously. Because the path back has to be symmetrical to the path that you go. In some way. So it's about figuring out the pattern there. But then I also, because while I'm thinking about this, I'm also thinking about how I'm gonna do that with the methods that I can use in C++, which is the most difficult part, I think. Although they repeat somehow, but yeah, this one is the same as this one. This one is not the same as this one. North, south, east, west, north, south. So they repeat here. North, south, east, west. No, it's not really. Yeah, it's not really repeating. I have no idea. I'm gonna look at the solution. It's practically over the time as well, and I'm tired already, so. Also, hash be 10. And you can also do for loops like this. I didn't know that. I think it's from C to. From C to walk. Where C is each char of the vector. This is very smart. So it's just making the coordinates based on these variables here. Ah, very, very smart, actually. Didn't even go to my mind to do that. Can I vote? I think this counts, yeah. So this is in count. Then checking if it's done in the beginning. Walk and E equals W. Yeah, I'm not sure if I get why this works. It's counting the elements from the beginning to the end. But yeah, I don't understand really well. So people are saying it's bad, actually. Same thing here. It's the same solution, actually. Well, apparently you can use AND on C++. And this is the same solution as the first one. Yeah, so I think I'm gonna watch these videos off stream again, the count ones, because I still don't get it really well, how to use them. But this is definitely a lot better, and I wasn't even thinking about doing this. So yeah. So I'm probably gonna continue to do these challenges another time, probably tomorrow. So see you then.